All right. Hello, grade 12s, amazing grade 12s. I say maths gamers more appropriately. I always say maths gamers because, yeah, maths is a game, guys. It is a game. Haven't you, like, haven't you seen it? I'm sure now, like, with 11 years of being in school, you've kind of seen how maths is a game. I think those who actually wake up to the idea that it is a game, they quickly realize, oh, okay, so it's just a matter of me learning a few of these rules, learning a few of the concepts, and then making sure that I learn, uh, do exercises, which is like it's like a stage of a game. You go to stage one, you play. Maybe at the end, the very last question is like the most difficult. It's like you're fighting against the boss. Then maybe the boss defeats you. You go ask your teacher, how is this question done? Teacher explains to you. Then you understand that thing, and you're like, oh, okay. Oh, it makes sense. It was fine. Not too shabby. Not too whatever. Let's move on to the next topic. You know? So some of you are, like I said, already are way ahead of what I'm doing right now or what I'll be doing right now. So please, people, I do advise you don't have to be here, especially like if you've done quadratic sequences. You dead set, you're fine, you're good, and like you are so far away. Like you even have done finished sequence and series. You are already doing inverse functions, or you already done with inverse functions. You are actually busy now with trigonometry. And like you are near done with trigonometry, you are close to actually coming and doing what is Euclidean geometry. So we may be at different places here. All right, so depending on who you are and how you'd like to actually utilize these sessions, please utilize them as you see fit. If it is that you are going with me and you actually have not even gone that far, you are actually still on quadratic sequences, and you are actually eager to hear the next segment of quadratic sequences, then you are in the right place. So we can kind of be on that journey together. But I do want to encourage you guys to utilize this beautiful textbook that you see in front of me. This Mind Action Series textbook. It's beautiful. Especially if you have it, you can do the exercises like to completion, like all of the exercises. Don't be content with just doing a few, but do all of the exercises. So do all of the exercises, and when you do them, all right, you are more than welcome, if you are already in my WhatsApp group, to contact me on the side and let me know I'm done, I'm finished, can you check my work? I'm more than happy to check your work, or to actually provide you with the means through which you can be able to check your work, and then you can give me feedback, as to like, hey, what did you find difficult, in accordance to what you marked, like what actually was the challenge, what was the struggle, okay, and all of those things. Ultimately, I want to be able to just be a resource of assistance, more especially to the grade 12s, just a resource of assistance, not your teacher. No, you have your teacher at school, he's fine, and she is fine, and you must respect and basically go in accordance with your teacher. But me, I'm just a resource of assistance, all right? Just an additional resource that you can contact you casually, or you can ask casually, or ask anything, all right? And I can assist you where I can, all right? I'm not taking the place of your teacher. I don't want to do that. That's not the purpose of this. This is just to enrich, assist, and also to support, all right? But more importantly, I want to encourage you to push where you are at, okay? Yeah, you push where you are at, so that you can make sure that you are as far as you possibly can be in the syllabus, because the more content you are able to cover on your own, and the more you can internalize things for yourself, then you will see, it will affect you, it will affect your performance. It will not help but bow down. I see what Oratile is saying there, that the revision is necessary even when done with the topic, which is, yeah, that's fine. That's an attitude of humility that I accept, and I'm happy for that. But I'm just saying that I know for some people they'll be like, so can't we do this, can't we do that? Please, this is not the place. You're not going to come here and dictate to me what I should and should not do. I am actually going according to a pace, and I'm starting somewhere, and I'm moving with a certain group of people. So that's why I'm saying that if you do feel like, me, I'd rather just probably get out of this live session and just continue for myself, then please do continue on your own. Ndazapora, can someone in the comment section just indicate that they are in that WhatsApp group so that they can actually then maybe get Ndazapora's contact details, or maybe share the link with Ndazapora so that she can actually then join. Olerato, for instance, Ndazapora just indicated I am, so you can actually just redirect or inbox Ujunia. Okay, so these are the people that are on there, and I really appreciate that some of you are actually really truly utilizing this thing of me. If I share, for instance, I give you some work to do, you guys are doing it, and some of you are reporting back, I'm checking your work and all of those things. That's good. Ultimately, like I said, I'm a resource to assist and help, and I'll help, and I will especially help those who are actually practically applying and who are putting in some effort, because I get catalyzed. I get catalyzed, by people when they actually do work and they want to share with me what they've done. I get catalyzed by that. Okay, all right. So let's get on. So yes, last time we started out with quadratic sequences, and we did how to find the general term of a quadratic sequence, how to find a specific term, how to find a specific term. For instance, if they ask you find the 20th term, if we already have the general term, people, then we can find the 20th term, because we substitute T20 in the place of T20 or 20 in the place of n for our quadratic sequence, and then we get the value of that specific term. Also, last but not least, how to find the position, guys. How to find the position. Yes. They hate Danta. You're asking what is the joining fee? It's free. It's free. And I know people, when they hear it's free, they're like, if it's free, then the value of this thing, it must be very low, because you pay serious money for things like this. No, guys, it's free. All right. It's free until further notice. For now, it's free. And what I do want more than anything else is for people to utilize it whilst it is there. Then you can see if it's something that you want or you don't. That's what's key here. That's what's key. And like I said, I get catalyzed when people actually do work, right? And they actually do follow up, and they don't just come in the sessions to just simply listen and not apply what they've learned, but to apply it and also give me feedback as to how things are going. That really fuels me. It fuels me a lot, right? So that's kind of like my payment, if you will. Also, on the live sessions, guys, feel free to comment and say things that you want to say about, and yeah. Okay, so let's go. So today, since we've covered how to find the general term, how to find a specific term in the sequence, and then also how to find the position, how to find n, right? What I had said last time is that I love this first few topics of sequences, because they help us to reawaken our skills of solving for unknowns. We get to solve a quadratic equation and things like this. We get the opportunity to learn how to substitute and then how to simplify. We cultivate our skills of algebra when we are doing this section. And that's why we cannot take this section for granted. And that's why we need to actually make sure that we do. That's why I suggest doing all the exercises in a textbook, especially if you have this one. If you have the Mind Action Series textbook, you do all the exercises. Don't just do 2 or 3, do all of them, so that your mind and your heart and your body can get into the habit of answering a certain type of questions when they are asked, right? And the more familiar you are with those types of questions, the easier most these things become, right? So please, grade 12s, do that. And if you do that, you will kill it, man. You'll be like, man, what's this? Maths is weak. That's what we want. We want maths to be weak, because it is. All right. So I gave you guys work, if you remember, and the work I had given you, it was so basic and simple, guys. That work that I had given you, it was so basic. If you guys remember very well, you were supposed to find the general term of 8, of 13, of 20, of 29. So obviously you first find the first difference and the second difference, right? Which is how, this is how you would do it. 13 minus 8, 20 minus 13, 29 minus 20. You get the first difference row, then the second difference, which is constant. Remember, we said that this first difference row gives us the arithmetic sequence. It's a linear sequence. Then our second difference for a quadratic sequence is always constant. You know, when we know these things, that's concepts understood. Then obviously expression, we'd use the expression 2a to find and equate it to the constant difference. We find a. Then we take 3a plus b, we equate it with the first term in the first difference. And then we solve for b, substituting a in the place of a, and then remembering our laws of transposing. When things get transposed, they change sign so that we get the right answer for b. And then last but not least, we use the expression a plus b plus c, equating it to the value of 8, which is the first term of the original sequence, and then we get our c value. Substitute a, which is 1 in brackets, we substitute b, which is 2 in brackets, and then we solve for c by transposing the 1 plus 2, which is 3, to the other side. 8 minus 3 is 5. And then don't forget, when you get the values of a, b, c, you then have to write down tn. Substitute it in that general term, a n squared. Remember, a is 1 in this case, so that's why we have 1n squared. The 1 is there, even if you don't see it, plus 2n plus 5. Are we together? All right. So, I mean, I'm sure we did all of them. The next one, we got tn is equal to negative 3n squared plus 2n minus 1. That was number 2. Number 3, we got tn is equal to half n squared plus n minus 3 over 2. Number 4, which for some was a bit complicated, and I think the part that got some people in a tailspin was the conversion of the mixed number, negative 4.5. Some people thought negative 4.5 is the same thing as negative 2. Why? Because they were halving the negative 4. Icon. Remember, negative 4.5, we write this as 2 times 4 is 8. 8 plus 1 is 9. So it's negative 9 over 2. That is the improper fraction. So it's like we are taking the negative 9 over 2 and we are subtracting minus 1, which gives us negative 7 over 2. We get negative 11 over 2 and negative 15 over 2 as our terms of the first difference. All right, and this is something that some people, they were unable to do. Right, so let's not forget. Remember, converting a mixed number to an improper fraction was something that we learned in grade 7. Then we took it up in grade 8. So at this stage, you are in grade 12, you should be able to comfortably do that, right? And then the subtraction of the terms, T2 minus T1. Please, people, let us not make mistakes of signs when we subtract and get the first difference terms. Then this is the constant term, negative 2, negative 2. Then ultimately what that helped us to do was to find the value of A, find the value of B, find the value of C, and we were supposed to get negative n squared minus half n plus half. That was for number 4. Are we together? All right, so this is just, guys, a quick review, man. I'm not really spending too much time. Then there was this question, B1 and B2. All right, negative 1, 1, 7, and 17. Okay, we were told it's a quadratic sequence. So if that's the case, we were told to find the value of the 50th term. Remember, if we want the 50th term in the pattern, it means we cannot do this question by inspection. We need to find Tn first. Okay, so we first find Tn. Because we were told it's quadratic, we know the quadratic general term is an squared plus bn plus c. So we need to then find the first difference and the second difference from the original quadratic sequence. So we get 2, 6, 10, and then the constant difference, that's a second constant difference of 4 and 4. We take 2a, we equate it with 4. We find a is equal to what? 2. Then we take the expression, we equate it to 2, 3a plus b, we equate it to 2, which is the first term in the first difference. We get a value of b is equal to negative 4. And then ultimately, guys, we get a plus b plus c equated to negative 1. We get a c value of 1. And then don't forget to write the expression Tn is equal to 2n squared minus 4n plus 1. And after you do that, you can then go and find T50, the 50th term. Remember, 50th term means we substitute in the place of n 50 so that we can get what the 50th term, in this case is 4,801. Okay. And then the next question was basically asking us to basically find out what is the position, which value gives us 6,000, which term, gives us 6,961. And remember, for this question, we equate Tn with 6,961. All right, remember Tn, we had gotten it, it's 2n squared minus 4n plus 1. We equate it with 6,961. Then we have to set up a quadratic equation, because this is a quadratic type trinomial. We get 2n squared minus 4n minus 6,960, which gives us n squared minus 2n minus 3,480. Now, I know some people at this point, they don't even bother factorizing, but they use the quadratic formula. But please take note, when you do use the quadratic formula, at least show the substitution of A, B, and C in the quadratic formula, so that for method marks, you can get those method marks. Don't just write n squared minus 2n minus 3,480 and then voila, we see the answers. You must at least show the substitution, right? I factorized here, but you must, if you use the quadratic formula, show the substitution. You must use the quadratic formula in your calculation. If you use that calculation, please show it, all right? It's very important. Then two answers. N is equal to 60 or n is equal to negative 58. But we know that our position of this particular value of this term can never be negative, of course, because all positions are natural numbers. So n has to be 60. That means term 60 is equal to 6,961. It is term 60 that is equal to that. We conclude in that fashion. Even though we have the value of n is equal to 60 and we have actually obviously excluded this negative value, but this is what we need to ensure that we have at the very end. Very important. Okay, guys, C as well, C1 and C2, same sort of drill. I'm sure you guys saw same sort of drill, because you were first asked to find the general term, find a certain value of the term, and then last but not least, you were asked to find which term in the pattern is equal to minus 1,034. And then you're supposed to equate Tn with minus 1,034. Remember, your Tn was actually minus half n squared minus half n plus 1 when you actually utilized your what? When you utilized your expressions and equated them to the relevant values, right? So then ultimately we were able to get n is equal to 45, okay? Whether in this position you use the quadratic formula or not, at the end of the day you were able to get these values, and you were supposed to have been able to get that it's term 45 that is equal to minus 1,034, because this one, n is equal to negative 46, we cannot utilize that as a position of a term. Okay, all right, so that was just a quick review of the corrections that you should have. I mean, the game challenge that I sent you guys yesterday. Today we're going to move forward with the next type of questions that have to do with quadratic sequence, and then after that we will conclude quadratic sequences so that we can actually move on to arithmetic and geometric. And I understand that some people are already so far away into these other sections, which is cool, and I'm very happy that you guys are far away. Keep it up, ne? Yeah, sure, ne? Let's go. Let's look at this. So what we can conclude is that a quadratic number pattern has a second constant difference nature. All right, so the constant difference is found in the second difference, all right, for a quadratic number pattern. And this can actually be used to solve equations for unknown terms. I repeat, your second constant difference nature of your quadratic number pattern can be used to what? It can be used to solve equations for the unknown terms. Okay, by this, let's look at an example. So let's say if we have negative 2 and x and 8 and 19 and y, and this is a quadratic number pattern, and we have to determine the values of x and y. Look at this. We have negative 2, we've got x. We don't know what x is. We've got 8, we've got 19, and then we have y. We don't know what the value of y is. We are told it's a quadratic number pattern. So that means this is a pattern that would basically have a second constant difference. Now we are asked to determine the values of x and y. Okay. So we're going to utilize what we've just learned, that a quadratic number pattern has a second constant difference nature, meaning that the second difference is always constant. And therefore, because of that, we can solve equations for unknown terms. So let's look at this. We have how many unknown terms? We have x, which is an unknown term, and you have y, which is an unknown term. So if we list the terms, negative 2, x, 8, 19, and y, this is our quadratic sequence. Then if we look at our first difference for these terms, this is what we would do. This is term 2 mostly, it's x. This is term 1. So we would say term 2 minus term 1. What's term 2? It's x. And we need to subtract what? Subtract negative 2. So this is like saying x minus 2. Remember, we are subtracting, but we are subtracting a negative. So it's like saying x minus 2. What's x minus 2? A negative times a negative gives us a positive. So that means our first term in our first difference is actually x plus 2. Let's look at the next term in our first difference. We are going to take the term 3 minus term 2. That means 8 minus x. There it is, 8 minus x. Let's look at term 4 and term 3. We say 19 minus 8, we get what? 11. And then let's look at this one. This term minus that one, y minus 19. That's the expression. So these x plus 2, 8 minus x, 11, and y minus 19 are our first difference terms, which we know form an arithmetic sequence. Let's take this first difference and get our second difference, which we know by nature. The second difference is actually what? It is constant. So we would take 8 minus x and subtract x plus 2. So I'm just going to write down. It would be like saying 8 minus x, and then we subtract. Don't forget, this is a binomial expression. So if we have subtraction, we have to put that binomial expression into what? Into brackets. So that will leave us with 8 minus x. We take the negative, we distribute it inside the bracket, minus x minus 2. We add and subtract like terms. So what do we get? What's 8 minus 2? We get 6. What's minus x? Minus x. Minus x minus x is negative 2x. So we have an expression of negative 2x plus 6. That is our first term in our second difference. Let's move on. This term, 11 minus 8 minus x. 11 minus. Now this is a binomial, so that means we write 8 minus x. We distribute the negative. So that means we have 11 minus 8. We distribute the negative as well to the negative x plus x. What's 11 minus 8? It's 3. And this x is positive. So we have an expression of x plus 3. Are we together? Hopefully so far we are together. If anyone is lost, please just comment in the comment section. I may be going too fast maybe for some or whatever, but I hope we are all on the same page. So sweet far. Right? Then, if we look at our last two terms in the first difference, take y minus 19 minus 11. Now, what's nice is that this is not a binomial term, it's just a monomial. So y minus 19 minus 11. That's simply saying the answer is y. What's minus 19 minus 11? It gives us negative 30. So we have a y minus 30. Thank you so much, Ghana, for actually, Ghana M1, thank you so much for actually letting me know that you are with me. Because I do feel like I'm alone here. Y minus 30, which is the expression y minus 30. So we have 1, 2, 3 terms in our second constant difference. And what do we know about these terms in that second difference? We know that those terms in the second difference are actually what? They are constant. So can we solve for x? If we look at the three terms, negative 2x plus 6 and x plus 3. We could equate these two because they have the same variables. And we could, because of this variable, which is x, which we can equate these two expressions, we can then find x from equating these two. All right. Now, let's turn our attention and check at something else. Could we equate negative 2x plus 6 and y minus 30? Like, equate these two? No. Why? Because y and x are two unknown variables. Equating these two from the get-go will not assist us in solving for x and for y. So if we look at x plus 3 and y minus 30, could we equate these two from the get-go? No, we can't. Okay. So what we do first is we equate the two expressions from our second constant difference that basically have the same variable. So we say negative 2x, we can equate it with what? With x plus 3. They have the same, they have a variable x in them. So when we equate them, we can then solve for x. Transpose the x, we get negative x on the left. Transpose the positive 6, we get negative 6 on the right. What's 3 minus 6? It's negative 3. What's negative 2x minus x? It's negative 3x. Then when we solve for x, we divide both sides by the coefficient of x, which is negative 3. We divide both sides by negative 3, because x is equal to positive 1. Okay, so far so good? I hope so. But we want y. So after finding x, to find y, what do? We replace in the expression x plus 3, this x is equal to 1. We can replace in the expression x is equal to 1 in the expression x plus 3 when we would have taken x plus 3 equating it with y minus 30. Now we can take x plus 3 and equate it to y minus 30. Why? Because we already have the value of x. We can now do that. But only now as something we can do after finding x. We can equate x plus 3 with what? With y minus 30. Why? Because we can replace in the expression of x plus 3, the value of x is equal to 1. So in the place of x plus 3, we substitute x, and we substitute in the place of x 1. Followed by what? Plus 3 is equal to what? Y. Minus what? 30. Then we can solve for what now? For y, using the value of x that we've just gotten. But hey, how important it is to make sure we get the value of x accurately. So that means this grade 8 solving for x equation, this is a grade 8 solving for x question, guys. I mean, no doubt about it. I mean, at this stage, we should be able to solve this without even breaking a sweat, with 100% accuracy. We should be able to even get the expressions of these various terms in our first difference and second difference without breaking a sweat. We should be making no errors, absolutely none at this stage as grade 12 learners, because our maths should be on point, you know. So we substitute, like I said, 1 plus 3 is equal to y minus 30. What's 1 plus 3? It's 4. Y minus 30 on the right side, we transpose negative 30 to the other side. What's 4 plus 30? That gives us, 4 plus 30 gives us 34. Remember, the y was positive, okay, when it was isolated. If you take negative 30, you transpose it, it joins positive 4. But it joins positive 4 as well, becoming positive. So that means 4 plus 30 gives us 34. So y is actually equal to what? To 34, all right? So we've just gotten what the value of x is. It's 1, and we've gotten what the value of y is. It is 34. And what did we use to do this, guys? We used our understanding that even though the first difference of a quadratic sequence is not constant, but the second difference is. And what does constant mean? It means same, meaning 1, 2, 3 are the same, which means we can equate things that are the same can be equated, but we equate those expressions that have the same variable first so that we can get an unknown first easily, like we did with x, because we couldn't get y first. Then we use what we've gotten to then find what we don't know, which is the other variable, by taking that expression and equating it with another one. Remember, y minus 30, if we wanted to, we could have equated it with negative 2x plus 6. Substituting in the place of x the value of 1, we would still have arrived at the same answer. All right? Can we feel these? Can we feel this, brothers and sisters? Are we feeling it, guys? We're going to be crossing over to the next year. Diisani, where we can relax. Diisani, are you in grade 12 by any chance? Dineoma, are you also in grade 12 by any chance? Crystal clear, Ghana one. It's awesome. I'm glad it's crystal clear. Now, since it's crystal clear, the only thing then that is left to do. Udineo was like, please. Udineo, I asked if it's school holiday, and then he's like, please. You're funny. You guys are hilarious. Thank you so much, Junior. Dineo must definitely stop vandalizing the comment section. She's vandalizing it like insanely. Alright. Yeah, vandalizing it insanely. So, for the purpose of that, we utilize then the textbook to basically do E, right? To do D. We want to solve for x in the following quadratic number patterns. So the first one, 2, 8, x, and 26. If you've done this already, then great. But if you haven't as of yet, I'd like you to actually do it. Solve for x in the following quadratic number pattern, 2, 8, x, and 26. Please do that. Dineo, I think it's time for Dineo to actually be removed. Thank you so much, Dineo, but I think you need to bounce. Being too negative. Okay. So solve for x in the following quadratic number pattern, 2, 8, x, 26. That's the first one. Thank you so much, Nuri. Really appreciate that. And then the next one, 6, 3x minus 1, x, and minus 3. So these are 1, 2, 3, 4 terms. You guys need to solve for x for number 1, 2, 8, x, 26. Okay, remember these are quadratic number patterns, guys. And then this one, 6, 3x minus 1, x, and minus 3. So please utilize your understanding. Yes, this is still revision, guys, for grade 11, but this is for grade 12, right? These are grade 12 learners because we revised this at the beginning of the year in sequence and series when we begin it, before we jump into arithmetic and geometric sequences. So yes, please, this one, and then E as well. Okay, if 3x, 11, 21, y is a quadratic number pattern, determine the values of x and y. Okay, that's your number pattern. If it's what? If it's quadratic. So we must always check with our statement. Please, guys, don't ever just jump in and read and answer a question, especially after you are finished and done with all of sequence and series and you are starting to do exam type questions. Don't ever just rush in and answer the question. First, read and check what type of pattern are you dealing with. Because remember, a quadratic number pattern. Okay, number 2, this one. Oh, you want to see this one? Okay, let me show you there. So number 2 is 6, 3x minus 1, x, and minus 3. Okay. Okay, so that is solve for x in the following quadratic number patterns. You're welcome, Ghana. And then number E. if 3x 11 21 y is a quadratic number pattern, determine the values of x and y. Okay, yeah. Then the very last one, this one. The general term of a quadratic number pattern is given by, I'm hoping that in grade last year, sorry, actually I'm saying last year, as if like we're already in 2025 and in this, but I hope you understand in the academic year that you were in grade 11. Hopefully you guys also, this is grade 12, but grade 11 obviously relevant as well for those who were doing grade 11 this year early. Here we are told the general term of a quadratic number pattern is given by Tn is equal to negative brackets n minus 50 the whole thing squared plus 20. So this is Tn, and this is the quadratic general term written in this form, right? And when it's written in this form, there's a couple of things that you should be able to conclude about when the general term is written in this form. You know, things like, do we have the highest value, or let me say the maximum value, or do we have a minimum value, or do we, and what is the term, which value of the term gives us that maximum or that minimum if there is a minimum? How do we know it is a minimum value? What sort of things indicate that it's a minimum? What sort of things indicate that it's a maximum? Okay. Now what they want is, what is the constant difference of the number pattern? What is the constant difference of the number pattern? That's the first thing they want. And then lastly, which term has the, so here highest value. Highest value would suggest that we have a maximum. What is the maximum value and what is the value of this term? Which term has the highest value? That's what they want first. They want to know which term has the highest value, and then lastly, what is the value then of this term? And I mean, these are things that you can actually deduce or read from the quadratic general term. Okay. Yeah, so these are game challenges I'd like you guys to do. I'd like you to do these, please. And please, when you are completed and done, you can send those to me privately. Where? About the minimum and the maximum. All right, let me just do that quickly, so that at least there is some sort of understanding, right? So let me just say Tn is equal to, now you guys know that an squared plus bn plus c, this here is what we refer to as the general quadratic number pattern. It's the general term, right? We usually find a, b, and c so that we can find the specific general term of a specific pattern, right? Yeah. But this is quadratic in nature, right? Because we have that n squared, so it's quadratic in nature. When you did functions last year, all right, you guys, grade 12, subordinate. When you did grade 12, grade 11, sorry, this year, in the grade 11 syllabus, just like in functions, if you remember in functions, you had y is equal to ax squared plus bx plus c. This is quadratic function, right? But then a quadratic function type, you also got this y is equal to a into x minus p, the whole thing squared plus 2. This was called the turning point form, all right? And from that, depending on the a value, if a was less than 0, that would suggest that a is negative face down. If a is less than 0, meaning this, if this is negative, that would mean we have a max value, because this face down means at the top there's a maximum. The turning point is at the top. Remember that? Then if A is greater than 0, that's happy face, but it means that we have a minimum because at the bottom we have what we refer to as the minimum. Right? So this was turning point 4. So in the same sort of like nature or attitude, your general term for a quadratic number pattern exhibits sort of like the same form. So this is quadratic in nature, but obviously if you're talking about shape and form, let's say if you have n minus p squared plus q, this is very important, right? Here this a would tell us something about, but remember the shape, right? If a is less than 0, then it would be like having a quadratic pattern. But remember, a quadratic pattern is not continuous. It is discrete. But the shape that it would form if a is less than 0 would be a concave down shape, a sad face in a sense. But we don't connect these dots, guys, because these are values of terms. But it goes from smallest all the way to the biggest value, and then it goes down. All right, so that suggests that if this a is less than 0, we have what we then refer to as a maximum, because it kind of mimics the same shape that a quadratic function has if a is less than 0. When a is less than 0, we have a maximum. Does that make sense? So that's why we say that when a is less than 0, it exhibits sort of like the same shape in that it has a maximum. All right, it has a maximum. We don't connect the dots, like I said, because this is not a function. It's a discrete. It's discrete in that we don't join the dots, right? I hope that makes sense, because these are terms. But in these terms, we list them. They go up, 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 and there's a maximum term which has a certain maximum value. Okay, so this maximum term, how do we find out what is the position of that term? Okay, what term is it? Is it third term? Is it the fourth term? Is it the fifth term? How do we find that out? We simply find that out from the following. You take this expression inside the bracket, n minus p. You equate it to 0, and then you solve it. This will give you the term number. All right, this will give you the term number. So you take this expression n minus p, you equate it to 0, and then this n is equal to p is actually what we refer to as the term number. All right, it's the term number. Then this q here will give you the value of that term number. Okay, so I hope that makes sense. All right, so whenever you are given a general term of a quadratic sequence and it's in this form, a will tell you, if it's less than 0, you know you have a maximum value. If a was greater than 0, you know you have a minimum value. All right, so I hope that explains. The person was saying, sir, can you please explain the quadratic number pattern in this form, this whole thing of maximum and minimum? So how do you know if it's a maximum? When a is less than 0. How do you know it's a minimum? When a is greater than 0. Did you see what the value of a was for that quadratic sequence, the form we had in the question? It was negative, so that suggests that we have a maximum. That's the first thing. But then you are asked 2 questions. You are supposed to tell us what is the term number of that maximum value, and then give us the actual maximum value. So how do you find the term number? Take the expression inside the bracket. What do? You equate it to 0, then you solve for n. Or you can take the additive inverse of negative p. That will give you the value, the term number, all right? The term number. Then if you want the value of that specific maximum term, the value of q gives you that. Q as it is, q as you see it, is the value of that term number. Okay, so I don't know if that is clear. Who was asking the question? Can you please, Sammy was asking the question. Oh, so you got it, ne? Yeah, so this is what you guys had actually learned in your grade 11 syllabus when you were doing number patterns. So in grade 12, at the beginning of number patterns, we revised this with you so that by the time you start doing the fuller extent of other patterns like your arithmetic and geometric, at least you have the basics of what you did in grade 11 solid and sorted. Okay. Give number 14 there. I don't know, there's a heartbeat there emoji. I'm trying to find one key. What's happening? Why is there a crying yo? Is there got a yo and a crying? What's happening there? You better tell us. Level 14 gift, even a level 14 gift that we got today. Okay, so exercise. It's Ghana M1. It's actually exercise 1 in the new Mind Action Series textbook. It's there. Okay, so these are the questions. The first question was solve for x in the following quadratic number patterns: 2, 8, x, and 26. Okay, so I'm just gonna give you 15 seconds. Is to write D1, then I'm going to move to the next one, D2, right? And just D1, you can see most. So for x in the following quadratic number patterns: 2, 8, x, and 26. Okay. Grade 12, grade 12, Miss Yo. I'll just call you Miss Yo because I don't know that name that you have there. Olerato, mind, see the mind born. Yeah. So these are two authors. I actually know the guys who are the authors of these two textbooks. Okay, I know them. So Mark Phillip is the author of Mind Born. Then Basson is the main author of Mind Action Series, especially so there's the old Mind Action Series textbook, which is basically a combination of what Basson and Mark Phillip wrote together combined. So the old Mind Action Series is their work together. Then they've actually decided to now sort of like fly as independents with the textbooks. So Mind Born is the work of Mark Phillip. The new Mind Action Series is the work of Jack Basson. And I'll tell you this, they both have their merit. They are not the same, but they both have their merit. If you have the old Mind Action Series textbook, then you have Mind Born. But the new Mind Action Series, it's the one, eh? I can tell you that. So, but if you have all three resources, that's great, because that will help you a lot. Then you have a buffet of questions that you can actually practice from, and that's good. Okay. Number 2, 6, 3x minus 1, x minus 3. So what are we wanting to find here? Wanting to solve for x in the following quadratic number patterns. Okay, 6, 3x minus 1. Okay, so these are 4 terms. We have 4 terms: 6, 3x minus 1, which is a binomial term, x, and then minus 3. Sean Sia, are you? Yeah, it has to be bought. Yeah, but it's expensive. You have to buy it. All right, but you guys should, like, if you already in the WhatsApp group, let's join the WhatsApp group, guys, and be part of the movement, so that at least I'll take pictures of some of the questions so that you guys can actually do them. Okay. And those who are practicing and are further ahead in their syllabus and work, and maybe you are already ahead but you are utilizing this specific textbook, then that's great. You can always forward me your work. I'll get to it and I'll send you the feedback, so that practice, guys, practice. Grade 12, practice makes permanent. If you want the content to be permanent in your mind and heart, you need to practice. If you guys are just simply gonna sit here and listen to me talk, it's not good enough, guys. It's not good enough. You have to go that extra mile and do the work, and do as many as you can until math is a game, until it's just familiar to you and it's easy. All right, so hopefully we've done 2. Then the next one was this one. If 3x, 11, 21, y is a quadratic number pattern, determine the values of x and y. If what? 3x, 11, 21, y is a quadratic number pattern, determine the values of x and y.